Hello folks, I'm Necati from Bilkent University. Today I'm going to present my physics 102 experiment. My experiment is about transformers. Transformers, transformers are devices that let us adjust the voltage of alternating current. We have different coils, 2 400, 1 800 and 200. And they are AC voltage source. It's about 6.7 volts. Now we have 400 to 200 coils ratio. This should give us output voltage of approximately 375 volts. And as you can see, our voltage is more like 2.9 because imperfect conditions of the transformer, we have losses. And now let's change our ratio of coils. Let's make it 400 to 400. This 1-to-1 coil ratio should give us the same voltage, give initial input, but as you can guess, it will not give the same voltage. It's about 5.78. We are about 1 volt of voltage loss. And now again, adjusting the ratio again. Now making it 400 to 800, 200 to, this should raise our voltage correctly to 13.5 volts. As you can see, we have about 11.50 just like I mentioned before, it's just an imperfect transformer. Transformer works are simultaneously changing AC current goes through this primary coil and creates a changing magnetic field through this iron core because it's changing, current is changing. This changing magnetic field creates a changing magnetic flux. And according to Lenz's law, changing magnetic flux induces currents through this secondary winding. So while it's proportional to the winding turn number, this magnetic field formula has N and I in it. When N is like doubled, I is halved, but conservation of power requires us to make V times I stay the same. So when I is halved, V should be doubled. That's why output voltage is proportional to output winding turn number. As for the second part of my experiment, I'm going to observe the effects of load on output voltage and currents. We have, in setup wise, we have 18 kilo ohms and 10 ohms of resistors here. We have a multimeter with set up to milliamp per mode and 400 to 800 transformer. Its output is normally 11.7 volts. Now, in current wise, this relatively high resistor doesn't allow much current to pass through it, so it's very close to 0.65 milliamperes. Now changing to other resistor, we have here 10 ohms. As you can see, the current is skyrocketed to about 200 milliamperes. Now changing to measure the voltage. As you can see, this high resistance, which doesn't let that much current pass through it, doesn't have that much load on it, and it doesn't change the output voltage that much from 1170 to about 0.06 or 7 voltage drop. It's not that much. It's about 0 volt. Now with 10 ohms, as you can see, the voltage dropped about 1/6 of it, like 1.97 volts. That's about 1/6 of it. It shows that the higher load the system output of transformer has, the lower potential difference it will have in the cable.